So in this video, we're going to talk about how to convert between logarithmic and exponential form. So you can undo an exponent with a logarithm. So let's suppose we want to solve the equation 2 to the x equals 55 for x. You can solve for x by taking what is called the logarithm of both sides. So this is what a logarithm looks like. It's read as the log base b of x. So this number down here, this value of b, is called the base of the logarithm. So we can convert logarithms to exponential form. What I like to do is draw the arrows, and so we can convert this to b to the x equals y. Okay, so that's the exponential equation that is the same as this logarithmic equation. I just wrote it in the reverse order, so y equals b to the x. And that's true as long as y is greater than 0 and b is greater than 0, and b does not equal 1. The value b is called the base of the logarithm. Notice that when we rewrite it in exponential form, it becomes the base of the exponential equation. So let's practice rewriting these logarithms in exponential form. So we're going to draw the arrows to help us out. So this becomes 2 to the third equals 8. The log base 4 of 1 becomes 4 to the 0 equals 1. Log base 12 of 12 becomes 12 to the 1 equals 12. And the log base 1/4 of 4 becomes 1/4 to the negative 1 equals 4. So notice that in these problems, we have some special logarithm values that show up. Anytime we're taking the log base b of 1, that is going to equal 0 for any base b that is greater than 1. This makes sense because if we think about rewriting this in exponential form, we get b to the 0 equals 1. And so remember that any number raised to a 0 exponent is going to equal 1, and so that's why it makes this logarithm have this special value. We also have the log base b of b. So if the base matches the number that we're taking the logarithm of, if we rewrite this, we can see that that makes sense why it's equal to 1. We have b to the 1 equals b, because remember any number to the 1 power equals that number itself. So now you can pause the video and try rewriting these logarithms in exponential form. So remember, draw the arrows to help you out when you're converting from logarithmic to exponential form. Notice that we have two examples where we have those special properties, right? The log base 7 of 7 is 1, and the log base 14 of 1 is equal 0. Now let's go in the reverse direction and let's rewrite these as logarithms. So you can see here we have exponential equations and we're going to write them as logs. So I always like to start off with a base because the base of the exponential equation is going to become the base of the logarithmic equation. So now I'm going to think about my arrows and I'm going to kind of do the problem backwards. So like if I was going to write this, it'd be like 5 to the whatever's over here. So it's going to be 5 to the 3 and that's going to equal 125. Okay, so that's rewritten in logarithmic form. It's going to be the log base 5 of 125. When I do problem B, I'm going to do the log, and then remember the base of the exponential equation, it becomes the base of the log. So the log base 121, and then over here on the right side, I'm going to have the exponent, so 1/2, and so that equals 11. So now you can pause the video and try writing these two equations as logarithms on your own. Okay, so remember, use the arrows to help you out. So this is 6 squared equals 36. And then we have 10 to the negative 1 equals 1/10. So remember that logarithms are the inverses of exponential functions. You can convert between logarithmic and exponential form using the relation the log base b of y equals x means that b to the x equals y.